Good morning. I hope you're doing well. I had a bit of a, frantic morning this morning. It's always the case. I always feel like I have plenty of time before the stream. I was ready like 25 minutes in advance, but then everything just kind of like crescendos right into the final minutes. And so I didn't, very busy. But I think everything's good. I think we're all set for hopefully an extremely exciting stream. There are a couple of things that I want to discuss before what I'm sure you're all waiting for after seeing the thumbnail for this stream. But yeah, hopefully, fingers crossed, Jugglebot will be able to throw and catch to itself while moving the hand back and forth, which is a massive step forward. This will be the first milestone that has been ticked off in almost 2 years. So big day, maybe. We'll see. Oh wow. Lawless, I am impressed. I'll try to cut through the preliminary stuff here. Should be pretty quick, so hopefully you can stick around for the throw attempt. It's gonna be pretty good. Also, for reference, so that you're aware of what I've tried so far, like in testing up leading up to today, I've done everything up to putting a ball in the hand. So I've had Jugglebot moving through the pattern that it would be moving through when it's throwing the ball back and forth, and it seems fine, but I've never tried it with a ball yet. I've been wanting to wait until now, until the stream, to try it with an actual ball to see what happens. So we will see. It looks good though. It looks, as far as I can tell, everything seems fine, but we'll see. All right, so the first thing that I want to talk about is that the catches previously, last week, were late. And this was observable in the catches in last week's stream, if you were really paying attention. John, who is very familiar with these catching profiles, noticed it. But yeah, they were a smidgen late. And I also had one attempt at throwing a 1 second duration throw before changing anything else. And I didn't pay too much attention to what was going on during this throw because the only reason why I tried it is because people were over at the time and they were like, oh, cool, it can throw as high as I was showing in the stream last week, but can it throw higher? And I was like, well, yeah, I do have a trajectory saved for a higher throw, but I've never tried it before, so let's just see what happens. And it turns out the hand just smashed into the end stop and threw a bunch of errors. And so I was a little bit like, oh crap, like maybe this isn't working as well as I thought it was, like what's going on? But it turns out the system is extremely sensitive to the spool radius that I have for the hand motor. So if you remember, the hand motor it's like the same motor as this, and it's got a spool sticking out of the end here, and the string wraps and unwraps around that spool. And the value that I set in the code for what the radius of that spool is, turns out matters quite a lot. In hindsight, this is pretty obvious, but it does matter. So previously it was 4.725 millimeters because I could measure it, and it was, the diameter was whatever double that is, 9 point something. I'm not good at math anymore. So that's the measured diameter, but of course the string has some thickness. Now the string is quite thin, so I'm like, well, maybe it doesn't actually matter that much. But now, after adjusting this to 5.134, just a mere 0.4 millimeters off of what it was before, now things work fine. And the catches are like so smooth. I really see what John was talking about when he was saying that it's just extremely satisfying to watch the catch come in and have it be perfectly smooth. And you'll see that in not too long. For completeness, the way that I got this 5.134 measurement was by moving the hand just manually down to the very bottom of its stroke, seeing what ODrive thought the position was, moving it all the way up to the top of its stroke, and then seeing what ODrive thought the position was, and then saying, okay, well, we have this many revolutions according to the ODrive report, and I know how far it has actually physically moved, so we can just like divide one into the other and get what the effective radius is. Mere 0.4 millimeters, it's tiny. Cool. So next thing is that now the flat platform is actually genuinely flat, which is quite nice. Mostly. The reason I say mostly is because the way that I set this up is by getting Jugglebot to throw the same throw the same height throw that I was showing last week in the stream, and then watching where the ball hit on the hand before it like rocked back in, and then tweaking the angle of the platform just a tiny, tiny bit, like 0.1 degrees at a time, until it landed straight in. And this so far has been good, but it's really, really hard to do this by eye because it's really hard to see what's going on once it's moving fast enough. So I did this with the height that I showed in the stream last week and got this offset, so 0.6 and 0.2 degrees. But I've noticed that when I'm throwing higher, and I'll show you this in a sec, the ball doesn't land perfectly straight in the hand anymore. So when it's being thrown higher, it's more sensitive to any tiny, tiny little angle offset, and that's causing the ball to land just not like squarely in the hand. But it's really hard to adjust this because when the ball is thrown higher, it's moving faster, and I can't see what way it's moving along. Thank you, the vintage tape. I'm happy to have you here. Cool. So yeah, it's flat, but it's not quite flat. And this, yeah, a slow-mo camera will make this a lot easier. So that's a little bit of a spoiler or foreshadowing for future weeks. We'll see. See how we go. All right. I think this is the last thing before we can get to it, but I'm very surprised by this. The CAN bus is so strong. It's so good. You may remember a little while ago, probably months at this point, I did some testing on the CAN bus where I was just sending messages as fast as I possibly could, just like a blank, empty, nothing message. And I wanted to see, the intention of this was to see how many messages I could send per second before I was unable to send any more. And the failure mode that I was seeing then was that the buffer, like I basically just couldn't send more messages in. And there's a buffer for transmission that can like hold a certain number of messages. I think the default is 10. And it will hold those 10 messages, and then when there's an opening in the CAN bus, it will then empty that buffer into the CAN bus and then be ready to continue. And I reached a limit, I think from memory it was 5,600 messages per second, where if I sent many more than that, of course I didn't try like 5,601, I went up to like 5,800 and that sort of stuff. But the practical limit that I could find was 5,600 messages per second. And if I sent any more than that, then my transmission buffer would fill up and the whole thing would just come crashing down because no more messages will be able to be sent out, and it just wasn't working. So I was a little bit nervous about trying faster message rates with the hand. The reason why I would want to do that is because the faster we can send messages to the hand, the more precisely we can control it, and that's extremely important when throwing the ball higher because the timing there needs to be really, really, really spot on. So I tested up to 500 Hertz for the hand commands, which remember is 3 messages. It only really needs to be 1, but until ODrive updates their firmware, it has to be 3. And also telemetry, so this is feedback. So this is position and velocity of the actual motor while it's moving around. Both of these were all 4 of these messages were 500 Hertz. So that's just for the hand, that's 2,000 messages a second. It's crazy. And thankfully, there was no observable problems. So yeah, I was pretty impressed by this. The most extreme bus load that I could generate was when the Space Mouse was controlling the platform. So this had the platform, its position or its pose being updated 100 times per second and all of the legs moving to accommodate that change in pose, as well as this 500 Hertz for the commands and the telemetry. And nothing seemed like it was stalling or anything. Like the Space Mouse control seemed as smooth as it normally does, and the throwing seemed fine. So of course it didn't catch because there's no way I can move the Space Mouse accurately enough for that, but it seemed all right. The only issue that I detected at the time was that the rate that messages were being published for the hand telemetry, which should be 500 Hertz on the dot, and it is when I don't have the Space Mouse control on, that dropped to 498.935 Hertz, which is a very, very small drop. I think it's like it's definitely less than 1%, way less than 1%. So I don't think that that's that bad, but I don't know. There is another problem that has been coming up that I'll talk about right at the end that I think is related to this, but everything seems fine now. But then the crazy thing about this is that the message rate peaked at almost 12,000 messages per second, which is like way more than double what I was previously able to get. And even the theoretical calculations, assuming, well, making some assumptions about like the size of the messages being sent, which may be why that assumption is not valid, or why that calculation is not valid. But using that calculation and some assumptions, I calculated that I should only be able to get around 8,000 messages per second. So I don't know how the heck this is working, but it does. So that's good. All right, let's see what Jugglebot can do. So I have some cameras set up here. Hopefully this view looks good. I want to walk you through the steps that in terms of like my level of confidence about what works. So first up, we can turn it on. We can launch it. I would love to be able to show my like Linux view at the same time, but unfortunately there's just not enough screen space in one measly video stream. All right, so it has turned on. It's found the encoder indexes. Now we want to home it. All the axes are homed. And now we can auto level. So we'll go up, wait for a second, and then, I don't know if that little tiny movement was visible on the camera, but it makes a little, tiny little adjustment. And now it should be flat. It reads that it is. All right, so let's do what we did last week first up. So we've got the ball in hand. So last week we did this, and you'll see now, actually, I've done this a little bit dodgily. I've done it so that when I send the first trajectory, that first one activates the hand and like gets it ready to throw. It works. So then the second time I call this, it actually does throw. So this is what we had last week, but now it's so smooth. Like there's no sound of like the ball hitting the hand. Like before it was like a nice, a solid thud, but now nothing. Let me move this camera up a bit. So smooth, so good. Beautiful. All right, let's go a bit higher. And let's move this one up as well. All right, so that works. And we can throw up a little bit higher again. That's a 0.6 second throw time. And we can go up again. 0.7. I'll do 2 of each. Of course, this is not proper juggling yet. This is just throwing up and down, but we'll get there, we'll get there. I want to show you everything it can do before we push it too hard. This is 0.8 seconds. It's throwing higher again. Now we can start to hear that it's a little bit, it thuds in the hand a bit. So I'll get a bit closer. I don't know if the microphone can pick that up, but there's definitely a bit of a less smooth catch. Yeah, but anyway, that's 0.8. So now we can do 0.9 seconds. That's definitely an appreciable thud in the catch. Maybe one more. But it still catches, and it's still like pretty smooth. One thing that I've noticed that like really wigs me out a bit is how there's zero spin whatsoever on the ball. Like I can see there's a little like dimple on these balls where they fill them up, and there's that dimple is like right there. And if we throw, it's right there again, exactly the same spot. Of course that makes sense given the way that this is throwing, but still like as a human with a lot of experience having thrown balls up in the air, they always spin, because the way that we throw them, it like kind of rolls them out of your hand, but it's uncanny how little spin this has. It's like literally in the exact same orientation that it was before. It's crazy. All right, so now this is the highest throw that I've got a trajectory for, which is 1 second. If we'll get there. So that's pretty good. So we can see that the hand is definitely moving a little bit early still. Yeah, still a catch. And I've got to say, that collision just then reminded me, I am extremely glad I've printed off little, let me show you on the camera, oh, whoops. Still need to get used to these controls, apparently. I've printed off some little caps on all of the O drives because in here, which one is that? 2. Yeah, these ones. Yeah, all of the plugs come out of here, like just cables stick out. And I am extremely glad that I printed these little covers for them because especially number 5, O drive 5, which is like right in front of the hand, just keeps getting hammered by balls like it did just then. That ball landed directly where those cables are. So yeah, I'm glad I've got those, otherwise those cables would have been screwed a long time ago. All right, cool. So we can throw high, and that's cool. Once we throw past a certain point, the timing starts to become a bit more of a problem, and I'll talk about that a bit more later. But with lower throws, so if we go back to 0.7, it's still smooth. And this gives plenty of time, it should at least give plenty of time. What are you doing? Oh, I typed something in wrong. Yeah, there we go. It still should give plenty of time to move around. Like it's a good height. So this is the height that I'm using for movement throws. And let's try it without the ball so you can see what I've seen up to, and then we'll try it with the ball. Let me find the command. All right, throw continuous, just one throw. Okay, so now this should move to the side, throw, catch, throw, catch. I realize now, I made some changes to my code and I'm only just now realizing that I probably should have done it so that it only does one throw and one catch, but we'll see if it can do 2, I suppose. All right, let's see if it can do it. Oh! Oh! That's so good. Let's do more throws. Let's do 5. 5 back and forths. Oh no! Oh fuck, I was looking away then. I didn't see what happened. Let's try that again. I want to see how that dropped. That is so satisfying. I am happy to call that a juggle. Oh, okay, so that's it, that's gone. All right, so the ball is not, sometimes the ball is landing just, it's like rimming the hand, and then if it doesn't settle down in time for the throw, then the throw is obviously a bit wacky because the ball doesn't go, it's not right where we think it is. Oh, that's so satisfying. Oh no, first one. I need to make a thing to like, have it realize when it's dropped. Sorry, I'm blocking that camera. Yeah, one thing that I've been pondering a lot is that the O drive can actually tell when the ball is in the hand. Like it is sensitive enough that just the weight of the ball can be detected. So I'm considering, I don't know, there is a possibility of like setting this up so that it can actually tell when it's dropped. Like if it moves down, it's like, oh, it was easier to move down than it should be. The ball must not be in my hand. I don't know, something along those lines. Some sort of feedback to know if the ball is held. No, gone. That's interesting. All right, let's try one more time. Maybe with not 5. Let's just do like 2. Because both of those last 2 dropped really quick. Yeah, that first throw is landing like here. That's interesting. All right, so something needs to be bugging. But anyway, I don't care. I'm happy to call that. I've also, all right, I may as well show you now. I'm not going to try this with the ball in hand, but I actually made this whole like profile timing thing. It was like yesterday afternoon, and I was like, well, I've got 2 options right now. Either I try it and see what happens, but I didn't want to do that because I wanted to wait until now. Or I keep going and do the logical next step, which is 2 balls in one hand. And that requires a lot more consideration with respect to timing. I'll talk about exactly what this is doing in a sec, but it's not doing anything remotely intelligent. This is very, very, very hacked together. And so you'll see, I mean, we can try my throw columns. So my idea is that this would be the easiest form for Jugglebot to do. Let me swap to my camera. So I'm figure that this would be the easiest for Jugglebot to do in terms of like 2 in 1 hand. And I've made a profile that is working towards that, but is definitely not good by any means. So it should go to like a flat position. It can throw, and then, so what it's supposed to do is move over here, throw, move over to the side, go back down, and then the intention is that I'll load the next ball into the hand, just manually, and then it throws and then goes back over, and that's where it gets up to, is going back over, and this will be then receiving the next ball. And actually, no, just for the sake of it, let's see if, no, I can't do that. I've made it end with the hand at the top. I should make it end with the hand at the bottom, and I can't easily change that. So I won't do that now. I'll do that later, because it's probably not going to work, but it works. That's amazing. I'm very, very satisfied with that. I'm very keen to update the banner for my channel and finally tick off goal number 2. That's so good. Let me turn the fan off. It's so loud. Amazing, amazing, amazing. Yes, Lawless is saying calibration might be out of whack after a few throws. That is a possibility. It shouldn't be. That shouldn't be happening. But you are right. Like one thing that I should do soon is to move the platform around to a bunch of different positions, check that the angle is what I actually think it is, and then also just like run a juggling session now that I can. And yeah, then see if the angle is still the same as what it was at the start, but at the end. Yeah, I should do that and just make sure that it's all consistent. That's so good. I'm very happy with that. Cool. Okay. So, I did want to talk about what this is doing. All right, I just realized I haven't actually made slides for what the hand is actually doing right now. So I'll just talk about it. Isn't the hand spool drifting when force is applied? I'm not sure what you mean by that, Lawless. The spool... It shouldn't be. Like, the string that is actuating the hand is fairly taut. I mean, it's actually... it feels a bit loose now, actually. I reckon that's it. I reckon that's it. So if we zoom in, we got camera 1. I can wiggle this just a smidge. I don't know if it's even coming up on the camera. But that's wiggling without moving the motor. That's backlash. And that wasn't there before. So this string has stretched a little bit, which is fine because it's really easy to adjust the tension thanks to John's brilliant tensioning mechanism. So that should be all right. I'm not sure what you mean by drifting. Yeah. Even when it's tight, the force it applies drifts. I'm not sure. I'm not sure. I don't recall drifting of any sort. But anyway, so what is going on right now is it's a very dumb procedure. What we have is the hand trajectory. This is generated beforehand. So I have a bunch of CSV files that contain all of the positions and the velocities and the torques that the hand ought to be at to throw the ball to the height that is described by the title of the CSV, or the name of the CSV. So that CSV is preloaded, and that's to throw the ball so that the ball will be in the air for a certain amount of time, assuming that it's being thrown straight up, which is a bit of an assumption that I've kind of ignored. Like that, honestly, that could actually be playing a role because I haven't done any sort of adjustment with the angle of the throw. Yeah, I've got a lot to say about that, but I'll continue with what's actually going on now. So that trajectory is preloaded. What I was calling when I was like sending commands is I'm saying throw this trajectory and I can like give it a number, and that number correlates to all the different CSVs, so I can tell it to throw the 0.5 second throw height, or the 0.6, or the 0.7, or the 0.8, as we saw at the start. And what we're doing for moving the platform is right at the start, we move to like the launch position, and I have hard-coded, well, it's semi-hard-coded the throw and the catch positions, so it can't really, I'm curious to try different positions. It should work. I should be able to change that and have it still function, but time will tell. But yeah, so at the start it's going to that first position, and then it's carrying out the hand trajectory, and then as soon as we detect that the hand has slowed down by, as soon as we detect that the hand is slower than it was 10 frames ago, then we can be pretty confident the ball is out, because as soon as the hand starts slowing down, then the ball will continue on without the hand and go on its merry way. So as soon as the hand has started slowing down, we then send one single command to move the platform over to the other side. The rest of the calculations to figure out exactly what all of the motors need to do to get there is actually carried out by all of the O drives that control the legs. So I'm using what's called trapezoidal trajectory mode, but all that really means is that I can just send a target position and it will just move there as fast as it can. This is one area that could definitely do with some improvement. So the way that the hand is being controlled has as precise control as we possibly can give it, and this is thanks to John, who's figured out how to use the torque and velocity feed forwards, which prior to him doing this I had no idea what they really were. But the way that the legs are being controlled is a very dumb method. It's just like, go from here to here. And that means that we are very limited by the accelerations that I've set in the trapezoidal trajectory thing. And yeah, I'm expecting we can get a lot more out of the legs if we control them a lot more precisely. But that's what's going on now. So as soon as the hand starts slowing down, we move the platform, and then we just kind of hope that it's there in time for the hand to then catch. And it just so happens that with this throw height and with the spacing of the catch and the throw positions, the platform is able to get there before the hand needs to catch. So that's just really pure chance. Or the fact that I tried it a few times and it looked fine, but yeah, it could really do. This is about as sketchy of a way as I could imagine to do this. But it works, so that's good. And yeah, I don't know how this will hold up for doing more complicated patterns. We're definitely gonna have to make it a bit more intelligent than what it is right now. Lawless is saying the string moves on the spool / loses position. Oh, I know what you're talking about. That was for a slightly different design. Yes, you are absolutely right. So an earlier design had, I actually have it here. I was using a capstan spool that looked like this, and the string was just wrapped around the spool, and that had a problem of slipping. So if I stop the hand from moving with my pinky that's out of frame right now, I can still, it's actually a bit hard, I can still move the motor and have the string slip on the spool. That is an absolute problem. That is, definitely a problem, and would be causing issues right now were it not for the fact that this string cannot slip the way that it's currently set up. It's actually tied in the middle to the spool, so there's no way that it can slip. It can stretch, which is possibly what's happened now, but it cannot slip, no way. All right, so I've got a couple more things to discuss. I have some questions for anyone who is familiar with ROS. One thing, so I mentioned before that I have no observable problems when I'm running the system at a high bus load. And so this is the 500 hertz of the hand with all 4 commands, plus the 100 hertz of the legs, plus all of the feedback from the legs. No observable problems. However, sometimes when I send messages over ROS, they just don't get sent. They just enter the ether. And I think that happened once when I was showing you this just before. So an example of this is I'll publish a message to this topic while I'm also echoing that topic in another terminal session, and the echoing just reports any messages on that topic. And there's no, the session that's echoing it has no receipt of the command. It's just no, nothing's happened. We're just waiting here. So the thing that has sent it, it says yep, it's been sent, it's all out, but nothing ever receives it. And I have no idea what's going on with that. Maybe it's quality of service related, but I don't really know. The second thing is, how can I have a directory inside my resources folder? So I have a resources folder that I am using to hold all of my some various files. For example, I have the ODrive DBC files, which are needed for the CAN bus so that it can decode all of the messages. But I'm slowly just filling this up with all of my different trajectories that I'm generating here. And I really want to have a folder inside here for the trajectories and just put all of these in there just so that they're out of the way. And I've tried what I thought was the obvious approach, which I have a link to here. There's links to this code in the description as well if you want to check it out yourself. But I tried what I thought would work, which is just to like add a line here in my setup file. But this didn't work, and I get an error that I can't copy this because this file doesn't exist or is not a regular file, whatever that means. So I don't know. I've tried a couple things. Well, yeah, mainly these two commands, but neither of those worked, and I'm not sure why, because that seems like it should work to me. Like, this is grabbing the resources folder itself, so surely this should grab the throw trajectories folder from inside resources. I don't know. I couldn't find anything online about this, so I'm not sure if, I don't know, I must be doing something weird. Yes, and this is a very shot in the dark thing, but if anyone has any tips for installing Qt 5.14.0, specifically that version, Joe on Zulip has suggested that I look into using a CAN logger on the Jetson itself. I showed last week that I had a CAN logger set up. I think it was last week or the week before. I was really excited about this CAN logger that I had set up, but that uses an external laptop, and that's a massive pain in the ass for me to have to like have a separate laptop here just for that. And it wasn't even that good of a setup anyway. But if we can get this set up on the Jetson, it means that it can all just be run there locally. It'll be really easy to access, really easy for me to use. For reference, the Jetson is on an ARM64 architecture, and I can get Qt 6 and above, but not 5.14. And the reason why I want specifically 5.14 is because the CAN program that Joe has suggested, it was designed to work with 5.14, and it says that most features should work with Qt 6 or more, but there's no guarantee that they will. Also, Qt 6 was like 14 gig. Like, what is with that? Surely it doesn't need to be 14 gig just to get this like CAN thing working. I don't know. I'm very confused about Qt. If you're familiar with Qt, please, if you have any suggestions, I would love to hear them. It would save me. I spent a lot of time mucking around with this, and I'm like, no, stuff it. I'm going to get Jugglebot to throw. I have a silly bug to report as well, which was so stupid. So my wait until arrival method wasn't working. And this may feel familiar because I was trying to get this working in the auto alignment process where I would get Jugglebot to raise up, wait until it has arrived at that pose, and then take its angle adjustment and then move. And that going up and waiting until it's arrived was the source of a lot of headache. I finally eventually got it working and kind of understand how it works with the async processes. Not async IO, but async in ROS using multi-threaded executors. But it wasn't working now. It wasn't working for the throwing thing. So what I wanted it to do was have it be in the middle, and as you saw, it should move over to the starting position and then throw, and then it can carry out its movement. But it has to get to the throwing position before it throws, otherwise the ball's going to go in some random spot. And it wasn't doing this. So I'd have it in the middle position, and then I would tell it to go through its sequence, and it would start moving just like a smidge, and then throw, and then go to the final position. So it wasn't arriving properly. And I was scratching my head about this for a long time because I'm like, what the heck? It's working for the alignment process, but it's not working 30 seconds later to do the throwing. What's going on? Well, I never reset the flag that tells me when the legs have stopped moving. I never reset that to false. So I have this code in can handler node, and this, oh, it's so zoomed in. This here, this function will tell me I don't really like this view. Joe has been suggesting I look at using pull requests, and I think I will. Yeah, so here we go. So we have this function for checking whether the platform has reached its target. And you can read through this code if you like. But the end result is that for each leg, we look at the set point, we look at the measured position that it's actually at, and we look at the measured velocity. And we then say, if the measured position is within some threshold of the set point, and if the measured velocity is lower than some threshold, so basically if it's stopped, then we say, yep, it's arrived and it's there. However, I didn't have this else it hasn't arrived thing. I never had it reset to say, oh yeah, by the way, if we haven't arrived, then we're not at our destination. So stupid, so dumb. And of course, the reason why it worked for the auto leveling was because that was the first time that this ran. So for the first instance, it sets them all to true once they have, like they're all originally false. Once they arrive at the first destination, then they're all true, and they stay true forever after that. And so it was working for the first instance, but never again. And that was a lot of head scratching for such a stupid reason. All right, next thing. We have a basic logger up and running, which is very cool, and I'm really happy with this. So what this is doing is we're taking the hand telemetry, so the position and the velocity. This is the measured position and velocity of the actual motor. This is being logged at 500 Hertz. And this allows us to generate some really satisfying, helpful plots. Whoops. Like this one, where this was from a test where I was running like, this first section was running like 0.5 second throws, then 0.6, then 0.7, 0.8, 0.9, and 1 second throws. And we can zoom in, so like the 0.7 ones, we can see exactly what was going on, which is extremely helpful for debugging these things. And so we can see that the ball is still landing a little bit late, even on these 0.7 second catches that visibly seem very smooth. The ball is still landing a little bit late. For reference, we want that peak to be like right at the top of this. We want that like second peak to be in line with the first peak. This is also backwards. Negative is throwing up. I need to fix that. But this is really helpful. So this will mean that we can debug things, hopefully with a bit more, we can actually see what's going on here. Like all this rippling, like this is interesting. Good data. But the analysis will have to wait on that. Yeah, I really want to get this also set up for monitoring all the legs as well. And so the intention at the end will be that we can see exactly what's happened with all of the legs, with the hand, with everything in the entire session that we just run. So we can just, yeah, go back and like replay everything and see exactly what's happened. Super satisfying. If you want to see this data for yourself and plot it for yourself, if you're into that sort of thing, then it's all on GitHub and there's links in the description to this video. And yeah, you should be able to do it. I'll also, at the end of this stream, I'll upload the telemetry from the session that we just did then. And so you can play around with that if you want. Yeah. Also, I figured now is probably a good time to show the Qt graph of what the ROS network looks like now, just in case anyone's curious. And here you go. There's a lot going on. One thing that I've got another ROS question, if anyone is familiar with this, is how to show the Qt graph without a particular node. So this ROS bridge WebSocket thing is the node that allows me to set up my Jugglebot GUI and communicate with the ROS network like through the GUI. But I don't really want to see this. Like all of these arrows and all of these arrows don't need to be here because everything is publishing. Well, ROS bridge WebSocket is subscribing to every single topic. And so it's getting all of that information to allow me to communicate over the GUI, which is really helpful for that communication, but it really clutters up this diagram. And so I'm wondering if there's some way to like display this graph without that node, and that will clear up all of this garbage that doesn't need to be there. But in any event, if you're curious about how things are working, there you go. If you want to pause the video and actually I'll get rid of my camera so you can see the full thing. And yeah, you can pause it there and have a look around if you're interested. Okay, so next steps. 2 balls, 1 hand, big one. Also, get used to this notation. We're going to be using this a lot more moving forward. B is balls, H is hands. Pretty straightforward. This is a whole different ballgame to one ball, one hand, because timing actually matters now. We actually care about what's going on, and we need to make sure that the platform is in the right spot at the right time. We can't just assume that it's going to be there because it probably has enough time to be there. That's not a good assumption anymore. And to help with this timing conundrum, actually one more thing first before I show Juggling Lab, is that the way that I'm approaching this now, and like the way that I set up that columns throwing thing, is that I have divided the throw trajectory, which is using John's generator, which is amazing. That generator, actually, for full completeness, that generator is generating the throw and the hold and the catch. So that full trajectory is in that single CSV file. So when we had Jugglebot throwing one ball back and forth, the hand was actually being controlled at 500 Hertz the entire time. It was being told to stay at the top at 500 Hertz for as long as it needed to until it was ready to come back down again. That doesn't work for multiple balls in one hand, because we need to, before the first ball comes down, we need to move over and then deal with the second ball and then go back, and then we catch the first ball. So there has to be like a throw before that first ball has come back down again. So we can't just command the hand to stay at its one spot the whole time. We need to break the trajectory up. And so that's what I've done in that columns attempt, if you could call it that I showed before. I've broken up the trajectory into just the throw and just the catch, and I have manually, for now, figured out the amount of time that it needs to wait before the ball will come back down in that hand or in that position. And so I can throw. During that time when we're waiting for that ball to come back down again, we move over, we go down, and then we throw the next one using that throw profile, and then we move back, and hopefully that whole process of like moving over, down, up, across should take less than the amount of time that it takes for the ball to come back down, which is in this case 0.7 seconds. And then just at the right time, that the hand moves back down in the first position and catches the first ball. So there's a lot that needs to happen in a very short amount of time, and it requires breaking the trajectory up into all of these little segments so that we can like stitch them together. This is my biggest gripe with having the trajectories pre-assigned. So this is something that has come up a lot over the last couple weeks and months, is that it's a good idea to not need to calculate the trajectories on the fly and have them already calculated, ready to go, so we can just read from some CSV file and just spit it out. And that's really, really fast, very compute efficient because it doesn't really need to compute anything. But the problem is it's not really very dynamic. Especially now that we're throwing on an angle, that needs to play into the trajectory. So this means that when we figure out the trajectory and like fill up this big directory full of CSV files, there needs to be, like, for any given throw height, there has to be the straight throw, and then the angle throw, and then the angle a bit more throw, and then the angle a bit more throw. Like, there has to be so many different variants of that one trajectory, and that seems like it's going to form too much clutter. So, I don't know. That's just my thoughts for now. Yes, and so Juggling Lab is amazing. If anyone's interested in this stuff and has not seen Juggling Lab before, it's so cool. It's been a little while since I played with this, so I haven't seen some of these features until just recently. But the idea is that you put in a Siteswap notation, which you can read all about online. I'll put a link in the description to the Siteswap page, and you can read all about it. And then it will make this little stick figure that juggles it, and you can click on the stick figure to pause it. And really interestingly, you can drag these like nodes here are where the ball is being caught and thrown, and you can drag those around to change the timing, which is very cool, very useful. And something that I didn't realize until when I was playing around with this last night is that it actually shows you the profile that the hand follows, which is very reminiscent of my Bezier curve approach. And you can also move the hands as well, which is very cool. Super, super cool software, and this is going to be really helpful with getting the timing set up for everything. Yeah, definitely recommend. There's a link to Juggling Labs in the description as well. And yeah, so my final thought for right now is, what patterns should we get Jugglebot to try? One that I am really keen for is getting it to do like this sort of thing, where the balls kind of like cross each other, but kind of don't. This, of course, like functionally is the same as columns, but the paths are just really off to the side. And one thing that I'm very curious about is if we can do this, but in 3D. So rather than having them going like this, they kind of go like one goes this way and one goes this way. And I cannot do this as a human because I am horrendous. Like throwing a ball away from you, that's so hard to do. We are very good at throwing side to side. And this is a huge reason why I wanted to make Jugglebot the way that it is because it's agnostic to which way the ball is coming from. It should be able to handle balls coming from whatever direction it wants, aside from them hitting the very top here, which is a whole other thing. But yeah, that's a pattern that I really wanted to be able to do. But I don't know, what else? Like, if you have any thoughts, let me know. Of course, like getting it to do columns, but having the columns like move around so they kind of like doing this sort of thing would be cool. Anything that's like using the 3D-ness of it, I think would be amazing. But yeah, if you have any thoughts, I'm all ears. All right, cool. So that's the end of my prez. Very, very successful. Super happy with that. Yeah, very good. And now we are lucky enough to have John with us. So I will bring this up and hopefully this will all work smoothly. Let me make this full screen and go over to here. Okay, if you're unmuted, are you, John? Cool, I can hear you. Let me make you audible to our audience. All right, I think you should be live. Cool, thank you very much for spending the time here and seeing me and having a meeting. It's very nice to chat with you, and I'm going very well, as you can tell. How are you going? Yeah. John is not audible. It is doing it. It is doing it. Definitely minimum viable product vibes. Sorry, your audio source. That's why. Boom. Okay. Can you make some sound?
Yeah.
Cool. All right. You should be. Yes. You should be audible now. Let me make you a little bit louder.
All right. I'll say it again for the crowd. You call it sketchy. I call it minimum viable product. I think it's really good.
Cool. Thank you. Yeah, I think it can be both sketchy and minimum viable product.
It's always fun.
Yeah, this is something that I've contemplated a lot. Is that I remember for a long time I've been saying that once Jugglebot can do one ball, building that out to do multiple balls shouldn't take that long. But one thing that I had as like an assumption in that is that when it was doing one ball, I would get it to be doing one ball properly, like the correct way to do it. But I didn't anticipate me just kind of like YOLOing and making like a shitty thing that barely works, because that's going to mean that building more balls on top of that is not as seamless as I was hoping it might have been. But that's all right. I'm happy for it to take a little while. It's worth it.
I think what it starts to do is you start to get a real appreciation for what has to happen between a throw and a catch, like realistic times and dynamics. And even though the current robot maybe can't go as fast and throw as high and precisely to juggle lots of balls, you can, like, the challenge of going from 1 to 2 is pretty steep right now. Especially fully open loop.
Yeah, not having any feedback on the ball is tricky. Yep. Yeah, so do you have any thoughts on, I saw you taking some notes at one point.
The robot's not precise.
Yeah.
Oh yeah, I was just trying to remember all that's
we went through a lot.
I mean, we should talk a little bit about hand trajectory generator. Let's see. Yeah, I think open loop, like, you're going to run into limits of just how precisely you can throw, and then like how precisely you can position the platform to catch. But I mean, like, you start to see that at 1 second throws, you're obviously not always hitting the hand in the same time, and it's hitting late. And that's a good thing to talk about. I think that it landing late is kind of an interesting finding, and I see the exact same thing on my test hand. Which, by the way, it's really fun seeing it halfway around the world. It looks a lot like my hand, so that's cool. But it's interesting that it throws higher. It's like overperforming. And when I did some testing, I hung a plumb bob up in the air above it and took some reasonably accurate height measurements. And it actually was throwing it higher than you would predict from gravity and the time that it's in free fall. So there's like a bunch of stuff that could be happening that creates error, but like for it to be throwing higher, all of the things that like, air drag and
they go in the other direction,
the wrong way. So for it to throw high, I think what might be happening is there's some stored energy in the actuator, the string and the hand platform, and potentially also in the way the controller is working. It's trying to catch up to the command a little bit as it's getting up to speed, and it's just nudging it a little bit faster, so the real velocity is a little bit higher than what's commanded, and then what it thinks it's actually doing. Because even in the feedback, I see it's like it's doing a pretty good job of like peaking out right where we commanded it, and then it starts coming back down. But there's some difference in the physical system compared to the
model,
what's commanded. And when I test with different balls, it's really informative. So like putting like a cotton ball and a little ball bearing, a golf ball, ping pong ball, like I had a handful of things like that, and it's like wildly different times in the air, even for things with like pretty dense ballistic coefficients, like about the same in terms of like drag. So it's not just like the drag, it's like how much it weighs matters to like the velocity that you get out of the hand, even for a fixed trajectory. But for a given ball, I think it's it repeats pretty well. So like what I was able to do is tune the linear scale on the hand, so it was throwing it a little bit slower. You can adjust that down and get it to land in the middle of the height again. But I think that starts to change a little bit. So maybe there's a little bit of a map or some correction coefficient thing that you do on the throw velocity. But that's just to get it like perfectly open loop.
Yeah. There's one thing that I have not changed yet from your setup, which is the inertia ratio. That is something that I honestly don't really understand very well, is the whole like reflected inertia and that whole thing. And maybe this is a discussion that's better had on Zulip, where we can, I don't know, spend some time to like type out thoughts. But that's something that I haven't changed yet, and I've just left that as exactly what you have. I tried to like recreate using your ball mass and like hand mass and stuff to like see how you got those values, but in some of the cells in your Excel, it's just like a typed value. I'm like, how did he get that? Like, what is the equation that he used? It's like you're teasing me. It's like you got all these other calculations, then just like a typed value. It's like, what?
Sometimes it's just magic. Well, yeah, so we should hash out the details there, certainly. But basically what that's doing is it's adjusting the throw height so that you have more time to accelerate below the release point than you do, or more distance to accelerate than you do above the release point up to where you're trying to stop. And you can tune that so that basically what you want to see is the motor current when you throw should be the same as when you decelerate. And that's based on the inertia of the hand actuator with the ball versus the hand actuator without. And I didn't do any tuning of that with mine, so
I have a feeling that would help a lot. Like I was very surprised by how much changing that hand spool radius helped things, and this feels similar to that. It's like something that might only change by a couple %, but it's a couple very important %.
Yeah, it's trying to like make the best use out of the stroke of the actuator that you have, and then because what like at maximum throw height, you're gonna have like just full current up, and at just the precise moment you start decelerating down, and then just stop before it crashes into the up stop. So if you get that right, it's at least predicting that. But obviously, you can't get that close because if it's a little bit wrong, you obviously
Smash.
it's like braking too late in a race car. You end up off in the weeds.
Yeah. One thing just before we move on, I'm curious to know if this is similar to your data. So I've got this data here is the same one that I showed before, and you can see that like even like this set of throws was throwing to the same height, but the velocity, the peak velocity, remember that negative is throwing up, the peak velocity that it reaches is actually quite a bit different. So like the max here is like 4.42, and this one's only like 4.23. Like it's significantly less for the same height, well, what should be the same height throw. And I'm wondering if that is affecting things. I'm sure it is affecting things in a not a very good way. But were you seeing similar results with your telemetry?
I think it was repeating better than this. I can fire it up again and start taking some data now that we can go back and forth here a little bit. A lot of it, I mean, there's a number of things there. There's if you're logging it really fast, you won't necessarily miss it. But if you're not logging fast enough, you might miss the peak, and that's a little bit asynchronous to like when the commands are going in.
I have noticed that these peaks are very short. Like, so I think it could be a sampling rate issue. Like that looks like it's only one data point. Oops.
And yeah, and there is actually in the trajectory generator, well, on the catch, there's like a constant speed area. I don't remember if I did that on the throw side as well. It's unfortunately pretty wasteful.
There is. Like, it's very small on the throw. It's like 5% versus 10%.
Right, which is almost nothing. Like you might actually just blow through it and not actually command a data point through there unless it's really fast. But like either a constant speed or really like the next step improvement for the trajectory generator to try and like soften that is to do a minimum jerk trajectory where instead of having constant acceleration, you're like speeding up the acceleration and slowing down the acceleration linearly. And you'll like have kind of a flatter curve. You won't be able to throw as high for that given stroke, but it will probably help the precision of the throw velocity. So we could try that as a sort of improvement to the trajectory generator, but it's I don't know. Like I think what we have can go.
I think this is
far.
pretty good. Yeah, I think if this is, I think a more informative next step would be to tune my system perfectly for, like, make the code reflect exactly what's actually going on in the mechanical system. I think the inertias is the biggest point where that would be helpful as far as I can see. Because like your ball is a completely different weight to mine, and like I don't know, some of those values that you had in the Excel for mass don't line up with the values that I've got for like the linear guide and the hand. So it's very not synced up with what the actual robot is right now. So it's pretty surprising that it works at all. But I guess it's close enough.
That's part of the beauty of the closed loop controls. It doesn't need to be that perfect. And some of it, you just look at the data and you can kind of then tune relative to what you see in the data to get that feed forward constant.
It'd be nice if it was kind of from first principles, though.
Well, yeah, and that's like model anchoring, and then your simulation matches the, what you see in the real world. That totally happens in all kinds of systems. So that's normal. Sometimes it's not exactly as you predict, and you might be, there might be real physical reasons why it's not actually as you predict, or it might be sort of correcting for things that are second order, but it makes the model more accurate. Yep.
Yeah, so definitely some improvements to be made, but it works.
Let's see. So next step, you want to divide it up so you can do two balls. That totally makes sense. I think chopping up the trajectory generator, so it's really just doing a throw and a catch, and then you can space those out. It's probably just a fine way to do that.
Yeah, this feels more in line with what I've always been thinking of as the way to do this in terms of like the throw is one thing that's handled on its own, the catch is another thing that's handled on its own, and the stuff that happens in between differs based on the context of what we're trying to get the robot to do. So if we wanted to do like one ball back and forth, like what it did today, that would be one set of like throw, something happens in the middle and catch. But then if we wanted to change it so that the ball is thrown just like straight up and down, that requires changing other things in that like in the middle section. And yeah, I've always imagined this as having separate, like it handles the throw and the catch separately, and then that in the middle space can be done dynamically. And yeah, so I think this is a big step forward in that direction. Yeah. But of course the timing is tricky.
Yeah.
Although Jean-Marc's Jean-Marc's sleep thing seems to be working really well. It's been working very, very smoothly. It seems very precise.
That's for the 500 hertz command rate.
It's for that, and also I was using it also in my columns attempt to time when it needs to like move back to be in the receiving position for the first ball. And that seems like rough. I obviously haven't actually tested it yet, but it feels correct. But I mean, I don't know. I'm not like millisecond precise, so we'll see when it's actually being done. But it seems like it's as good as I expect it to be without having a real-time operating system, which is of course the real answer to this.
There's that. So one of the ways to kind of test this is to independently with that can logger look at the timestamps of the commands and the telemetry. The telemetry coming out of the O drives will be very consistent, although it may have to dodge the commands because those will block the telemetry from coming back, I believe. But like, if you look at the command timing from command to command and the jitter and spacing on that gives you a pretty good metric for how well that process is doing at feeding the commands on time.
Yeah, that's about as close to the actual receiving of the commands.
And to do that with and the pecan software I've used before it obviously is a little painful to look at, but it can log and then you can export to like a CSV and do some basic statistics on those commands, like filter on the same commands, and then because you should just see 3 commands come out back to back to back, and then sort of 2 milliseconds later see the next batch, and they're like 100 or so microseconds apart.
Yeah, pecan definitely seems like the gold standard there, but it's just so damn expensive. I think like all up, if I wanted to do exactly what I want to do, it'd be like 600 or 700 euros, which I don't even want to think about what that is in AUD. And I did message them, and they said that they don't sponsor individuals. So I'm like, well, all right, fair. So yeah, it's.
But you don't need to like decode the message. You just need to see like the timestamps of the 3 commands passing by for the hand.
Yeah, I could do that.
Will do, and I think you have it working with a different can logger, right?
I did. I had Busmaster at one point. It was like working as much as anything worked on my Windows 10 PC, insofar as like it worked for like a second and then stopped. And I haven't actually tried that on the laptop yet, but I expect it would work. Yeah. And yeah, you are right. Like, I don't know. There's kind of 2 purposes of the can logger in my mind. One is to do this, to like check the timing of everything, which you're right, I could do with the setup that I have right now, as long as I just like find the arbitration ID for the messages that I care about. But then the second thing is to make sure that the messages that are being sent are actually correct and that there's no erroneous messages going back and forth. And for that, I'd really want the DBC file upload. I don't want to have to sit there and like decode like 50 messages hoping that, well,
Sure.
Yeah.
And to some degree, this is also just what the robot controller is doing. I mean, you have the GUI that's displaying the data, so do you really need an independent one? Like the thing that you don't necessarily have with the ROS running in Jetson is like maybe the really good timestamps. So the CAN transceiver has those. I don't know what it takes to get those into ROS. You might be able to get real timestamps through ROS, but there's some, I guess, easy ways with a CAN logger to try and get that at least to like to I don't remember what the precision is. It's at least to a millisecond or a tenth of a millisecond is pretty common with these.
Yeah.
And even on like a Windows PC, non-real time, those timestamps are good. So if you have 10 or 1 millisecond commands, you'll see a nice even clock as recorded in that logger.
Yep. Yeah, I really want to get that set up on the Jetson though, so I don't have to mess around with having a laptop here all the time. Like it's kind of annoying. Yeah, but then of course that goes to the QT problem. It's just everything, like nothing is easy. Yeah. Well, very few. Some things have been, but
maybe not the long-term solution, but a quick insight to like, is it pretty good or is it terrible? Because if you're seeing like 20 or 30 millisecond jumps in time, like this can be a really big problem for good throws and catches.
Yeah, that's true. All right, I'll do that at some point soon.
Yeah.
Who knows when, but yeah, I think that is a good call. Yeah.
Well, anything else you want to pick my brain about?
Nothing I can think of off the top of my head. To be honest, I'm a little bit... It's hard to think too technically right now. But yeah, I'm very grateful for the points that you've raised so far. It's very, very helpful to be able to talk with someone who actually kind of knows what they're doing. It's been super useful.
I dabble in a lot, so.
Yeah, I can imagine.
Awesome.
Cool. All right. Thank you for your time once again. And yeah, till next time. Have a good one.
All right.
Get your own personal sign off. Yeah, sounds good.
All right. Take care. Bye.
See you, John. Oh, John's so good. All right. I think that's it from me. Oops, crap. Get rid of that. Get rid of that. I can get rid of these. Amazing. Actually, no, you know what? I'm going to do this now. I was going to do this afterwards, but I'm going to do it now for the sake. I've opened this up so that I can do it now. And we can update my banner. So exciting. This is... I've been thinking about this for a long time, as you can probably imagine. But it's finally time to tick off goal number 2. You can see the full banner in all of its glory. I really need to update this banner to have a more accurate Jugglebot. This is many versions ago was this design. But now, boom boom, juggle one ball, done. 2024, what's the date? 19th. So damn good. You can get there. Whoops. How good is that? Next, 2 balls, 1 hand. Who knows how long that'll be, but I have a feeling it will be less time than almost 2 years. And then 3 balls, 2 hands. 3 balls, 2 hands is going to be an interesting one because I'll need to make a second hand. And I think it might be a while before we have 3 balls, 2 hands because I have every expectation that I will never be building another version of Jugglebot that looks quite the same as this. I think the next version will... My thinking is that I'll make it a Core XY style, like very flat, like the whole height of the entire thing will be like less than half a meter, but it will just like zip around really quickly. And then the hand will be in the middle and that will obviously do the throwing. And this like Core XY system can like zip it around really, really fast. Very similar, actually. I rewatched one of Stuffmade's his videos, the one with the basketball hoop that moves around on his wall and it can like tilt to catch the ball. It'll be very similar to that, is what I'm imagining. potentially even with the tilting mechanism, maybe even on 2 axes, which seems mechanically very challenging, but we'll see how that goes. Yeah, but definitely not a format like this. So, but it'll be interesting to see if the 2 robots can juggle between each other, even with such a large height offset. I think that'll be really cool. One thing that I would love to do is you can kind of see Jugglebot has, let's see, this camera's good. Jugglebot's base, if you didn't realize this already, is actually a shape that tessellates. So I think it'd be amazing if I made the same, if I made future versions of Jugglebot have the similar sized base, and they can like fit into all of these grooves and kind of be around it. And if I had like 3 of the flat Core XY styles that I was just referring to around it, it'll be like one big Jugglebot in the middle and like 3 little ones on either side, and they can all kind of work together. That'd be pretty cool. But that's definitely not going to happen for quite some time. A long way to go before that. Cool. All right. I will upload my banner. So excited about that. And yeah, I'll see you next week. I don't really know. There's a lot of things that I've been working on in the last couple of days. I've really just been like band-aiding things on top of each other, and I'm in 2 minds about kind of like going back and fixing some of this stuff up to make it a bit more robust and a bit more legit, versus just kind of charging ahead and going for 2 balls in one hand. I feel like I'll probably go for the 2 balls in one hand. So maybe we'll have that. Maybe we'll have another goal next week. 1 week, maybe. All right, cool. I hope you found this interesting, as always, and good luck with everything you're doing, and I'll see you next week. Till then, have a good one.